A parent function, in this case it's y equals the square root of x, and it's asking us to do some translating. So the big thing, and if you're not remembering, this is a good time, you can use your notes as a guide. But these are things like you have those different rules. You might maybe want to make some flashcards just to start remembering those. So to the parent function, if it says I'm going to translate it down, that means outside of the function I'm going to subtract 2. 4 to the right means inside the function. We said if it was right or left, we do the opposite sign of what we think. So to the right, I would put -4. Okay, so that moved it down to the right. And we want to reflect it across the y-axis. So when I think about that, I'm going to pick it up and I'm going to flip it this way. If I want to flip it across the y, should I put a negative on the outside of the function or on the inside of the function?
Inside.
Inside, lovely. So if you put it on the outside, it would flip it across the x. So you just have to be careful. Once again, that's just a rule. You have to look it over and kind of know it. So if it pops up, you do the correct thing. So that would be your function, or your translation, I should say. Does anyone have a question with that? Beautiful. So last week, you had some stuff. What did you have? You had 2 jam boards in the Math Excel on Thursday, and then Friday you were kind of cutting and pasting the little puzzle. I think there was 1 or 2 in that puzzle that was messed up, or something repeated, so it wasn't perfect. So if you've noticed that there was one that was mixing up, don't worry too much about it. I did go through and check. I just quickly glanced. The nice thing about the jam boards is I could glance and see that you were kind of on the right track. So you guys were good with those. The Math Excel, I went in and kind of looked. If you did it, I gave you credit for it. So if you got an 80, you still got 4 points or 8 points, or whatever it was. So I'll let you know in Math Excel if I'm going to use your actual grade, because you might, I don't know, spend a little more time on it. Was there anything from last week, though, any of the assignments that people had issues with or questions on, or anything to clear up? Sorry, it's so hot today. I'm sorry. Okay, if you have a question, feel free to ask me. My after school days will be Tuesdays and Thursdays, so you are more than welcome to, well, you're here already, so if you ever needed to stay for a few extra minutes on a Tuesday, I will be here, and then I will also have the Google Meet on, so if you want it on Thursday to sign on. Math, unfortunately, isn't the easiest to email about, so if you ever do have a question, maybe it's a Math Excel question, either just screenshot it or take a picture so I can actually see what you're talking about. Someone tried to ask me a question, I had no clue what they were talking about, because it was just a random question on Math Excel. So just give me as much information as possible. That will help me respond to you. And we're just going to do our best at this point. Unfortunately, math is the one class that's just terrible to do online. And I'm sorry, because that's just going to have to be our life for a little bit. Sorry, excuse me. Hey, Ben, can you just put here in the chat? Lovely, thank you. And then your assignments are posted on Google Classroom. So just make sure they get done today. Other than that, you're all set with me. Sorry, it's lucky I left that on, so I meant to turn that off. So I'm sorry in advance, because once again, math is meant to be done on paper, but such is the way our life has to be for the next little bit. So just do your best. If you're having technological issues, don't freak out. Just let me know. I'll always give you extra time if there's a major issue. The Math Excel, it is attached to the book. We can all know math books can be a little bit, sometimes they're just worded weird. So just do your best. It does let you check your answer, and I think it gives you a few opportunities to redo problems. So please try to do that. If you don't get something right, please try to redo it to the best of your ability. And I think that's it. Any other questions or issues or concerns? Fabulous. So you need to have that worksheet out that was up there. If you didn't grab one, please grab it now. I'm going to put mine up. If I could find it. Give me a second here. 8,000 things up on my computer. Go. Erase So today and tomorrow, we're gonna be talking about piecewise functions. I'll kind of show you what that means in a second. So we're gonna be doing some evaluating, so plugging into them. We're gonna be doing some graphing, so that should be a blast and a half. And we'll also be reading some graphs and writing equations from them. Sorry, not very waiting for the projector to come up. There we go. So these are some guided notes we found. So me and Mrs. Keesley always work together. What I do, she does, and vice versa. And they were kind of just a good basis for what we're doing. So instead of confusing you with all sorts of crazy notes. So this is lesson 3.6. This is not 3.6. Sorry, I don't know what section it is in our book, but just as a heads up. But it is on piecewise functions. So a piecewise function is a function that has different rules for different intervals of the domain. So here's kind of what it looks like. So we're going to start with number 1. We're just going to plug into them. And then we'll do some of the graphing in a minute. So we see this as the function f of x. Okay, that's great. So we've seen functions before. But what I notice is for f of x is split into 2. So piecewise means there's different pieces. So this has different pieces of the function depending on what my x's are. So this is telling me if x is less than 2, I'm going to use this function. So if we had a 1 or an x is negative 10 or an x is 0, I would plug it into this function. And then it's telling us if x is greater than or equal to 2, I would use this function. So if x was 5 or 11 or 27, I'd plug into that one. So basically you have to read which one am I plugging into first, and then you would plug into the one that you need. So let's do number 1, A through C. Excuse me. So if I say f of negative 2, just as a reminder of function notation, f is the function. It's telling me that the x is negative 2. Okay, so it's just giving me some info. So I have to first decide which of these am I plugging into. So this is what I call the domain. I look at the domain. And negative 2 is less than 2. So I'm deciding I'm going to use this first function based on the x that it gave me. So I'm going to take this function. Where there's the x, I'm going to plug in the negative 2. So first is what function do I use? Now it's actually plugging into it. And now it's just evaluating. That should be pretty quick. Half of negative 2 is negative 1, minus 5 is negative 6. So that would be your final answer. So first, which one do I choose? Check your domain. Then once you have that, you're just going to plug it. So for B, when I say f of 2, okay, in the f function, we have 2 parts. I want to know where 2 would go. So you just have to pay attention to the symbols. This says if x is less than 2, and this says x is greater than or equal to 2. So since it has the or equal, this is the one I'm going to choose. So I'm going to use this function. Be careful, because if you kind of rush through that one and you didn't look, you might have chosen that one. So you need that or equal symbol. So I'm going to plug in my x, and then I'll evaluate. The actual math isn't hard, it's more just a setup. And then f of 4, I'll check my domain. 4 is greater than or equal to 2, so I'm going to plug into this one. And get that. So we plugged in, you guys have plugged into functions before, not a big deal. But since there's many pieces, you just need to make sure you're plugging into the correct piece. So can you guys try number 2? So number 2 gives us g of x. There's 3 pieces. Depending on what the domain is, you might have to switch which function you're using. So always check that first, and then plug into that correct piece. So can you guys try number 2, A, B, C? Well, I take attendance. Or I take your attendance, not remote attendance. Person attendance. So we get Jennifer, Megan, Marcus, Josh, and all of you guys are here. Thank you.
This one. 13 less.
1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Beautiful.
Remember, it's 4 less.
6, 6, 1, so once again, just plugging in, you just need to make sure you're plugging into the correct spot. So check your domain. Oh, I love last period. That's everything. All right, let's do a quick check of those. So when I say g of -8 is less than -6. Just be careful with your signs there. So I'm going to plug into -x minus 5. So it would be -8 minus 5. Your answer to that one should be 3, because a double negative would make that positive. For b, we have g of 1. 1 is in between -6 and 4, so I'm going in this part of my piecewise. So I'm going to plug into the absolute value of x plus 3. The absolute value of 4 is just 4, so we're good there. And last but not least is g of 6. So g of 6 would be in this last piece, because 6 is greater than or equal to 4. And all it says is -5, so there's nowhere to actually put the x. So your answer is just -5. There's nothing to actually plug into, it's just a constant. We call it a constant function. So that's just your output. There's no actual plugging in, it's just realizing once you're in that section, every output would be -5. So can you check your 2, A, B, and C? Are there any questions with plugging into a piecewise? Fabulous. Okay, so we're gonna look at some graphing now. Woo. Like 85% of this is just staying organized because you have a few different pieces. So I'm gonna show you what I do. If you come up with a different method, I'm happy for you, whatever works. Just make sure once you're eventually have to do this on your own, you kind of know what works for you. So this is our function. We have two pieces. We have the function 3x plus 2, which we should recognize as a line, mx plus b. So we know it's going to be linear. That's kind of nice. And that's only going to happen if x is greater than or equal to -1 and less than 2. Okay? And then we have this other piece, also a line, and that's going to be greater than or equal to 2, but less than 5. So I need to come up with like what these are going to look like in that section. So here's how I do it. Off to the side, I start with my first function. Plus 2. Under that, I'm going to make a little chart. So I need this piece. So I'm going to take parts of this piece and graph it, and it'll be awesome. So since this is an interval between -1 and 2, even though it's not technically equal to 2, it's just less than 2. 2 is still going to be kind of our boundary. It's going to be our endpoint. So we will denote that it's not equal to, but we are still going to use that point. In our x, I'm going to choose -1, and I'm going to choose 2. And I'm actually not choosing those. I'm just looking at the two ends of my interval. So whatever are on the end, you have to put here. You're going to see why in a second. So these are going to be two x's. I'm going to plug each of these x's in to find the y that corresponds to it. So if I plug a -1 in, that would give me what, -1? And if I plug 2 in, that would give me 8. So really it's just picking some points. I'm just picking them based off of what information it gives me. So remember back in the day, you guys have done this before, and you were dealing with inequalities and you put open circles and closed circles. Does everyone remember that? When do I put a closed circle?
When it includes it.
When it includes it, when it's equal to. And if it doesn't include it, I put an open circle. So technically we just put it there kind of as, to show us that's where it ends. It approaches that, but it never actually touches that. So what I do is I kind of remind myself of that at this time. X, I kind of read this backwards, is greater than or equal to -1. So at -1, I'm going to put a closed circle since it had that or equal to underneath. And then x is less than 2. Since there's no or equal to, we're going to put an open circle here. I'm an organizer. I like to organize everything first. Now I can graph this. It's just going to be a line. It's not going to be anything too excited. But at -1, -1, I'm going to put a closed circle. At 2, 8, I'm going to put an open circle. Sorry, usually I would give you rulers, but we don't want to touch things. So in the future, a ruler might be helpful. If you can bring one, you can use the side of a notebook or something. I'm just going to kind of sketch it. So I'm just going to connect between here and here. It's just a segment. It is a line segment. It does not go on for infinity. It's just in between those 2 points. So what we're doing, you look at the first part. You say, okay, what's my domain? It has to be between -1 and 2. So I'm choosing those as my x's. I'm finding the y's that go with it, so I have points. And I'm just seeing how do I put those points in with open or closed circles, and I connect them. I'm going to do the same exact thing for the second function. So I kind of go like that. So for the second part of the function, I'm going to make a little chart. So I go back. So we see it's between 2 and 5. So my x's are going to be 2 and 5. So I'm not just magically making these up. They come right from there. I'm going to plug 2 and 5 in to find the outputs that correspond with them. Lose my shoe here. So that would be what? -2 plus 8. That would give me 6. And that would be -5 plus 8, which is 3. So now I have some points. Okay, so it's not terrible to find the points. It's just going to plug them in. Before I put them on my graph, I'm just going to remind myself I need to look whether it's an open or a closed circle. So we can see at 2, it's going to be a closed circle because it's more equal to. And at 5, it's going to be an open circle. Okay. So I'm going to plot those points and connect them. 2, 6, closed. And 5, 3 is open. And I connect closed. So right now you're probably saying, okay, then what? That's it. That's what your graph's going to look like. It's not the nicest graph. There's 2 pieces of it, but that's kind of what a piecewise means. There's different parts of it. So you'd be done. There's nothing else to graph, nothing else fancy. We do need to label the domain and the range. So to do so, I'm going to show you 2 ways to do it. I don't care which way you do, whatever way makes you happier. When you look at domain, we're talking about the x's. So just think about your x-axis. So this is my x-axis. When I'm going across the x-axis, this is the first point where there's an x involved. And if I keep going over, this is the last point. So everything is in between here and here on the x. I went down a little just so you can see. So I'm going to say that my x's are in between -1 and 5. So you can write it like this. That's a closed circle, so it's greater than or equal to -1. And that's an open circle, so it's less than 5. That's one way to write it. Another way to write it is called interval notation. You use this a little bit more in pre-calc. For now, if you know it, great. If you don't know it, it's not going to really affect you. But you can write it like this, where the bracket represents or equal to, and the parentheses represents not equal to. So the bracket's kind of like a closed circle, and the parentheses like an open circle. So that's your range. Excuse me, that's your domain. I was looking at the word range. Our range is our y, so just think about it. You're thinking about your y-axis. If I kind of think this is the lowest point, I'm just kind of picking a random spot here. And if I go up, the highest point is here. So my y's are in between here and here, which range from y is -1 to y is 8. So we would say y is greater than or equal to -1 and is less than 8. Or you could also say, like that. So these don't actually mean anything, I was just kind of showing you it's between here and here, or here and here. Just a reminder, we talked about functions last week. This is a function. Sometimes when people look and they say, well, this vertical line goes through 2 points. It doesn't technically, it only goes through this point. When that's an open circle, remember it's not equal to that. So that's just kind of the end of our boundary. So just as a heads up there. But that's the idea. So we'll do another one. And well, that might be it for today, but that's okay. So before I start number 4, does anyone have a question? Reminding ourselves it's the first problem. The first problem always looks kind of weird and confusing. So we'll obviously do more, but is there any part of number 3 that people have questions on? Okay. So number 4, same idea. It's a piecewise. We have to break it into different pieces. In this case, there are 3 of them, so we just need to stay organized with what goes in each part. So I'm gonna kind of do all my work off to the side first, and then I'll graph second. So I'm gonna start with 3 different functions. I have f of x equals 2x. For this first function, we said x is less than 1. So you pick 1. You need another point for a line, so just pick anything less than 1. I'm gonna pick 0. Doesn't really matter, you can choose -10, I don't care. So if it just says less than, you pick the barrier point, but you also pick something less than it. I'm gonna plug both of these in, we can do that quick. That's 2, that's 0. And I notice there's no line underneath, so at 1, it would be an open circle. Okay? So just things to kind of remind yourself of. For the second part, it's just f of x equals 4. And it only happens at 1 point. It happens when x is 1. Oops, not 1. When x is 1, and it's telling me my output is 4. I don't actually plug into anything, it's just telling me it's 4. Since it's equal to, that would be a closed circle. But there's only 1 point for that one. And then for the last part, f of x equals x plus 5. What are we going to choose? Greater than 1. So we're going to choose 1. Because remember, we'll put an open circle there. So it's not actually equal to 1, but we kind of just need it. And then I'll choose 2. Just to do something that's greater than it. And if I plug it back into the functions, the outputs would be 6 and 7. And at 1, once again, I'm going to have an open circle. I like to do that first. That's just me personally. If you want to do a section, then graph it, go for it. But now that I've kind of set everything up and everything's organized, I have each different part and I have some points for them, I'm going to plot those and kind of see what happens. So I'm going to plot the point 1, 2 with an open circle. So that's what, if I had made that note to myself, I would have just totally drawn a closed circle. So that's why I like to make an explanation. I'm also going to put the point 0, 0. It's not really an open or a closed circle, so I'm just going to put a quick little dot there. It's just a point. So at this point, I'm going to connect those 2. That's going to be the first line. So it goes on infinitely, anything less than 1. So I'm going to connect it. I'm going to extend it. I'm going to put an arrow on it because it technically keeps going. That's a terrible line, but you get the idea. So first part's done. Second part is the point 1, 4. There's a closed circle, and that's it. It's not being connected to anything, it's just a point. So second part's done. Third part, I go to the point 1, 6. I'm going to put an open circle. And then I'm going to put 2, 7 on here. Once again, I'm just going to put a quick little point. It's not really open or closed, it's just on the line. And then I'm going to connect these 2, and that goes on. Oh God, that's terrible. That goes on forever. I'm going to put a little arrow. And that would be what your piecewise function would look like. So I'll give you a second. Sorry, I'm making sure my video is working. It is. All right, so we did all that fun work. If you realize, like, none of the steps we did were actually hard. We just like plugged into little functions. So it's more just about keeping everything in order, making sure your graphs are looking nice. The nice part about these is we're all lines. We will look tomorrow what will happen if we have something like an absolute value or quadratic. Those do pop up. But they should be pretty quick, nothing too crazy. So we just need to label the domain and range. So the domain, let's think about the x-axis and our points. This line is going forever. This line is going forever. I guess we should call those arrays, but we'll go with it. So when I think about the x's, if this goes forever, we include all the x's this way. This x is included, right, because that's a closed circle. And then all the x's are included that way. So we say, you can either write all real numbers, because basically you can take anything from a number line. The symbol for all real numbers I use a lot, it looks like an R with an extra leg on it there. So that's all real numbers. If you wanted to write it in interval notation, you would just write from negative infinity to infinity. So it's infinite. There's no restrictions on the domain. You can plug in any number you please. The range is a little tricky on this one. So if you think about it, like, okay, all these numbers are included in the range, blah, blah, blah. But then see how there's a gap in between these two, and then there's a gap in between those two. So you have to kind of note that with the range. So we would write y is less than, what is that, 2? So everything's below 2. Or y is equal to 4. Or y is greater than 6. So we have to split that one into 3 pieces, just because, see how there's little spaces in between those, so they're not continuous. You kind of do the same thing with integral. So a little funky, few different organized information way that's for these type of problems. So tomorrow I will see you. We will do 1 or 2 more of these. I'm just going to print out another sheet with some extra ones. They're kind of a pain just to do in your notebook, so I might give you an extra graph or 2, just to stay organized and have a few extra examples. And then the last few examples of that on that worksheet on the back is they give you a function and you have to write it